algebra unit. Today our learning target, you are going to be able to solve one-step equations through addition and subtraction. So in other words, the only operations you should use today is adding and subtracting. Okay? So you need some vocab when we talk about solving equations. For algebra, the heart of algebra is inverse operations. Inverse operation undoes a current operation. It's like doing the opposite. The definition isn't opposite, but it's like doing the opposite. It gets rid of it. Like one proton and one electron turns into a neutron, right? They get rid of the charge and there's no charge to it. It's the same thing with algebra. If you have -2 to get rid of -2, you would have +2. To have 7, to get rid of 7 or to undo it, you would do -7. That's why I say opposite. You're really just trying to get rid of it. Okay? And when I say solve this equation, solve means get variable alone. Figure out what the variable is. Like x equals something or a equals something. But the variable is all alone on one side of the equal sign. And algebra is about maintaining balance in an equation. Remember, equation has a root word equa or equal. So whatever you have going on, they're balanced out at first. So if you start doing inverse operations, then you have to maintain the balance by doing it to both sides. Or it's not an equation. It's not equal. You change the whole thing up. So what you do to one side of the equal sign, you must do to the other. And we're just going to talk about our 4 basic inverse operations. Remember, inverse is undoing something, also known as opposite. So, addition, what's the inverse of addition?
Subtraction.
Yep. Subtraction. For subtraction, what's the inverse of subtraction? How do you get rid of subtraction? Addition. You would add. Addition. Multiplication. To get rid of multiplication, what would you do? Huh? Divide. Yep, division. And to get rid of division, you would, multiplication is the inverse. There's properties of equality when we talk about solving equations. I just want to show you something before I move on with the actual lesson. If I had a true statement, a true equation, like 1 + 2 = 3. The addition property of equality tells me that if I add something to the left side, then I need to add something to the right side to keep it equal, right? So let's say that I added 1 to the left side. Notice that my left side then would be 4, and to keep it equal then I would have to add 1 on the right side. That's addition property of equality. You have subtraction property of equality, meaning if you subtract something from one side, then in order to keep it an equation, you'd have to subtract the same thing on the other side, and you'd get 1 = 1. Okay, so you have addition property of equality. So addition, write this down actually. Addition property of subtraction property of equality. And you have the multiplicative property of equality. There's tons of them, equality and subtraction property. And all these say is if you add something to one side, then in order to maintain that equality, you have to add it to the other side. So, just to put it in blunt form, add to both sides. That's to keep equal. To keep equal. And this is subtract to both sides to keep equal. Your homework today is going to ask you to identify a property. Like, why are they doing this particular thing? And it's going to stem from either applying the addition property of equality or subtraction property of equality. If they're adding a number to both sides, it's an addition property. If they're subtracting, Chase, a number from both sides, it's a subtraction property. Okay, so let's solve equations. Same thing you did in 6th grade with your algebra unit. You guys had a pretty intense algebra unit in 6th grade, actually. I've seen the 6th grade algebra unit. The only difference here is we include integers, so it's a little more difficult with that. The first thing you want to do is determine what inverse operation you're going to use. This is typically done in our head. You don't have to write that down. And then second, we do it on both sides. We are maintaining that balance. Okay, so first example, x minus 5 equals 10. My operation is minus 5. How do I get rid of minus 5? Plus 5. The inverse of minus is plus 5. In order to maintain that equality statement, I have to do it to both sides. So I get x equals 15. X is equal to 15. So I see that I'm minusing 5. The inverse of minus is add, and I do it to both. Okay, example B. Y plus 9 equals 15. I need to solve for y. So what that means is I need y alone. If I'm plussing 9, I need to get rid of plus. What's the inverse of plus? I'm going to minus 9. I'm going to do it to both sides. Again, the heart of algebra is I need to solve. Solve means get the variable alone. So I'm getting rid of everything that's by the variable. Y equals 15 minus 9 is 6. Have a good, I usually box off my values. M minus 8 equals negative 14. Do I move the minus 8 or the negative 14? Which one do I move? Say it nice and loud, class. Minus 8. Now some kids think that, oh, I'm just going to go like this. Don't do it, because that's not helping you. Remember, we're solving an equation. Solve means that you're getting a variable by itself. That just means I need to move whatever's by the variable, which is this. So to get rid of minus 8, I plus 8. Uh-oh, now we got to be pros at our integers. They're different signs, so you take their difference, make it negative, because there's more negatives. M equals negative 6. A plus 8 equals 10. What's the inverse of plus 8? Yep, so I'm going to minus 8 to both sides because I have to keep that balance. I have to apply the subtraction property of equality, meaning I do it to both sides. A equals fun. Actually, I love algebra. This is great. X minus 2 equals negative 4. Add 2. Getting rid of that minus 2. X is equal. They're different signs, so you take their difference, and it would stay negative because I have more negatives. X plus 9 is negative 6. So to get x alone, I need to move the 9 by applying the inverse to both sides. X equals, now it's negative 6 minus 9. They're the same sign because it's plus a negative. So it should be negative 15. Notice when I see negative 6 minus 9 like that, I right away look and say, hey, they're the same. The same means add, and then just make it negative. Y plus 5 is negative 1. Subtract 5. Again, my eyes are looking at this. They're the same. Same means add. Keep it negative. Y is negative 6. And lastly, subtracting 11 from 3, you get negative 8 equals x. I'm not a big fan of my variable being on the right. It makes me feel stressed out for some reason. So I always just flip it around. And it's okay. You can flip it. It's commutative. Equality is commutative. You can flip it. Okay, I forgot to put a heading in, and I want you to include it on the back side of your notes. I want you to write 2 signs in middle. And you need to know how to handle that, because that's another rigorous level of solving for 7th graders. That means something like this. If you have x plus a negative 2 equals negative 7. Notice you have 2 signs in the middle. You have plus and you have a negative. That's what I mean by that. 2 signs in the middle. What I want you to do, the to-do with this, is to do the inverse of first sign. That's what you do. That's how you handle this. But it gets a little tricky. So if I have x plus a negative 2 equals negative 7, I need to move the negative 2. How do I get rid of it? Well, I'm plusing it. So the inverse of plus is to subtract. So I need to subtract a negative 2. Well, according to the subtraction property of equality, if I subtract something on one side, then I need to subtract something on the opposite side. But what is minusing a negative? What do you really do, Michael?
Well, if like the two negative sides are next to each other, you do plus plus.
It's just plussing. So when you minus a negative, it's just plussing. So this is just turning to plus 2, plus 2. So you get x equals negative 7 plus 2 is a negative 5. You got this written down? And I want to do one more example. Please know that you want to be careful when there's 2 signs in the middle. Lots of students make mistakes with 2 signs in the middle. Let's make our signs minus a negative. So let's do another one. Let's go x